Test. Recording. So you're always supposed to identify that you're recording. So I'm recording. So nobody do anything that you wouldn't want on video. All right. I'm going to switch over and share screens. Eveline, can you see the screen okay?
Yes.
Okay. So when you first launch Civil 3D, this is Civil 3D Imperial. What does Imperial mean? Are we like stormtroopers on the Death Star? Dun, dun, dun. No, what does it mean? What does Imperial mean? Right, feet, inches, the Queen's inch. Right, we're not in metric. Ooh. Metric is awesome. Yeah, well, surveying still runs in feet. Okay. This is what you see when you first open the program. Now, personally, I think that's a little easier to see. Agreed? Okay. So what we're going to do is we're going to start figuring out how you're going to analyze your traverse data. Okay. So what do you have? You have angles and distances, right? That's what you have. So how do you generate that in a drawing space to make it meaningful to turn into somebody, right? To check or to start drawings from or whatever. Some housekeeping. When you first open this up, you've never seen it before in your life. There are so many commands in this thing, it'll make you guess. Don't be intimidated by that. Fiddle around. Okay. That's the only way you're going to get familiar. Okay. It's very similar to most Windows-based programs in the fact that it has this ribbon at the top. Okay. You can turn that ribbon on and off. Okay. AutoCAD has toolbars. That's these little things over here in the margin, down here. If you see something and you want to use the button for it, you can. If you want to type the command, line, so you have to be on the command line. Oh, you want to draw a line. Fantastic. Okay. So you can type it in, you can use a macro, which is the short version of, instead of spelling out the word line, if I just type L, it's smart enough to go, oh, you want to draw a line just by telling it L. Okay. Am I going too quick? Good. If you hover over one of the gray areas on the screen and you there we go. If you hover over one of the gray areas of the screen, sometimes you got to fiddle around to get to it. See how it says AutoCAD, Civil, Express, Lock? Okay. If you have a dual monitor setup at a workstation at your dorm or in your office, a lot of people will bring the tool buttons in for different stuff. So the two most common ones are Draw, okay, and OSnap, or Object Snap. Oh, snap. So what do I mean by that? Well, we'll get to it. So you want to draw something based on coordinates, right? You have coordinates based on the two benchmarks that you got from the NGS website. Remember this? If I tab over to there we go. If If we tab over to NGS's website, you'll see that I have there's the Colton benchmark, Centennial. So if you open up the data sheet for Centennial, okay, you have, I'm sorry. That's okay. So you have your height at NAVD 88, 348.94. Okay. But we're doing X and Y. We're doing northern and east. Just remember, CAD always sees X comma Y. Surveyors always see northern and east. So it's backwards. Okay. Just be aware of that. If you scroll down the list, see here, SPCPAS. Anybody know what that stands for? State Plane Coordinate System. So it's state plane coordinates. Pennsylvania, South Zone. So in Pennsylvania, it's divided into two zones, North Zone and South Zone. We'll talk a little bit more about that later. But you're in Pennsylvania state plane coordinates, PA South Zone. Meters. What is S feet? Survey feet. Is there a difference between survey feet and international feet? Yes. Does it matter a whole lot for the surveys that you're going to be doing? Probably not. Translating these out to miles and miles, yeah, it's rounding. It's how it adjusts, right? So you're in Pennsylvania State Plane Coordinate System, South Zone. Those are your coordinates, northern and eastern, right? UTM is a different datum. It's a different horizontal datum. You have horizontal datums and vertical datums. Okay. UTM, Universal Transverse Mercator. Don't worry, we're using those. Now, you can have like Notepad or something up and you can copy and paste these. AutoCAD gets a little finicky. It doesn't like commas at the thousands. Right? So it just likes the decimal point and that's it. I just wrote them down on a piece of paper. Do it however you want to do it. So now I'm going to go back over to CAD. Okay. In AutoCAD. So you have AutoCAD and you have Civil 3D. AutoCAD's lines are just drafting based. They're to make a picture. Civil 3D, almost all industries have gone to having the engineer, the designer, developing their drawings because the drawings are model-based. You used to do top, left, and right side views of something that were called orthometric views. Now, you're going to make a 3D model of this body and flip it and turn it and rotate it and do a slice through it. But it's one model. So everything has switched to being more model-based. That's why these programs have gotten so sophisticated. It's also why you need to know how to use them as a civil engineer. Or what we could do is we went over how to calculate latitudes and departures by hand. We could do it by hand. Anybody want to do it by hand? Okay. So we're going to show you how to do it with Civil 3D. First things first, we got to do some setup. Okay. In Civil 3D, you have this space over here called prospect. Okay. It's always up when you first open the screen. I haven't given this drawing a name. I will, but for right now I have. Okay. So when you first open it, you see how there's tabs here on the right side of it? When you first open it up, you're on the prospector tab. The prospector tab, so this is tool space, prospector. Tool space is also up here. So if you open it and this isn't here and you want to see it, you just click on the tool space button. This has prospector, setting, survey, and toolbox. You're going to spend most of your time in settings and prospect. The first thing you want to do with your drawing is we're going to go to settings, which is this middle tab right here. And then at the top, you see you have general, point, surface, all of this stuff. You'll eventually get there. You don't need to know what all of it is for now, but you do need to set up the drawing to get started. And I'll show you why. If you right click, okay, not select, but right click with your mouse, that'll bring up other menus. So you get this drawing setting. So you right click, hit drawing settings, and then this screen pops up. Units and zone, transformation, layers, and ambient setting. Right? Well, first things first. See how this has international foot and survey foot? Okay. What did the NGS sheet say? Survey foot. I'm not going to change it for now because I want to show you something else. See where it says zone? What does that say? No datum, no projection, right? I want to assign a datum. Now, keep in mind, that's still on international feet, yeah? Okay, watch. I'm going to select datum. I'm going to scroll down till you get to, the states aren't alphabetical until you get down to USA, because there's different countries in here. All right, go down to Pennsylvania. All right, USA, Pennsylvania. So that is my category, but I still am not there yet. So HARN, surveyors, engineers were horrible. We have acronyms for every damn thing. HARN stands for high accuracy reference map. You need to know what that is? No, it's important for GPS, not important for what you're doing. Okay. Categories. So what coordinate system were we in? Well, if you forget, you can always tab over. EA South Zone. Somewhere on here, it should say horizontal. Scroll up, maybe. Ah, NAD 83. North American datum, NAD 83. That's the horizontal. NAVD is North American vertical datum, 88. So you have a horizontal datum and a vertical datum. Anybody not with it? So we're looking for 83. Come back over. All right. There's a whole bunch, just like before. You see how you have 27 and 83? 27 in meters, 83. They're in, I'm sorry, 27 is just in US feet. 83, you have meters and feet. So I'm going to select South Zone, NAD 83, Pennsylvania State Plane, South Zone, US foot. You see how that switched and it doesn't let me change it? It knows that that coordinate system is in survey foot. You can't change it. So it's smart enough to know sort of where's Waldo. Where is it in space? The rest of that stuff you don't have to mess with. We good on that? How did you measure your angles? Did you measure it sexagesimal or did you measure it to decimals of a degree? Yeah, degrees, minutes, seconds, right? See how it says angular units, degrees? We are going to stay degrees, but now we're going to go over here to ambient settings, which is the last tab on the right. Everybody see where I went to those tabs at the top? So I'm at that last tab, and I'm going to scroll down to where it says angle. What format is it? Decimals. Anybody know what PIA is? how much of a PIA would it be to sit there and convert all of your angles to decimals of a degree? Wouldn't it be a lot easier if I could go in here and tell it, do it in degrees, minutes, seconds? No conversions. I'm digging, right? So change your format. But you see where it says precision? It's only going out to 4 decimal places. Is that enough? No. We're going to change that and we're going to go up to 8. Anybody not with it? And I keep going. Okay. Always make sure you hit apply down here in the lower area, because if you don't hit apply, it's not going to remember what you just told it. It's not going to save those settings. So make sure you hit apply. The other thing you want to do is, I'm going to save this. Now, the first time you save something from scratch, it's going to ask you where you want to put it. So if you put it on the local C drive, if you put it on the cloud, if you put it on a US, wherever you put it, that's where it's going to look for. Right? So I have my USB drive plugged in. And I'm just going to call this lines and points. You can call it whatever you'd like. But when you submit the drawing, the digital version of this, when we get there, I'm going to want you to put your crew's initials and stuff like that. More on that later, but that's just saving. Now, you want to get in the habit of saving relatively frequently. This is a pretty sophisticated program. You could ask it to do something, and all of a sudden it's going to be like, what? I'm done. Shut up. It's gotten better over the years, but if I'm doing grading on a subdivision and it's generating those lines, those contour lines for feature lines and 3-dimensional strings, everybody see how that's a lot of data? So it could get locked up and frozen and just shuts down. It happens. It happened to me yesterday. So if you spend 4 hours working on your title block, it should not take 4 hours. I'm hoping. I'm hoping. If it does, I'm sorry. And you don't save it, and I'm sorry, I can't help. I'm sorry. There's nothing I can do. So just get in the habit of saving relatively frequently. Okay, so the 2 line commands that you need to know are drawing lines by coordinates and drawing lines by turned angles. Okay, that's pretty much what you did. Okay, so everybody should have located the benchmark between Pardee and Colburn, right? You should have coordinates on that. And somehow you should have closed back to that, right? Or closed your loop. And you should have coordinates on the spire. And we're going to talk about how you get the X and Y on the spire of Colburn Chapel. Nobody climbed up here, right? Because that would be worth some extra credit, but I'm not endorsing. No. This isn't paralegal stuff. No, I do. Do not do that this weekend and send me a selfie from the top of no.
There's a lot of parents on campus. I don't even think that'd be possible if someone tried.
I'm not even suggesting it because knowing my luck, somebody would do it. And I'm only here for 1 semester, so let's not. No. Nico, please, you're killing me. Okay, back on track. AutoCAD has ways to draw lines. So does Civil 3D. Civil 3D's ways of drawing lines are more specific for a surveyor and an engineer than a draftsperson. Anybody ever see old photographs of the drafting room when they were working on the Titanic? One engineer is walking around this huge room with these big boards of drawings, and there's like 50 people working on drawings. Right? Where am I going with that? Those lines are just drafting. It's a stupid 2D image. You're not making a model. Civil 3D is model based. You're actually creating a surface model of something, a road cross section of something. Okay. So lines when you first open the program, you just get this single line of commands. Okay. To get the line of commands that I just had up, see where this says Civil 3D and it has a gear and it has 2 down arrows, and the one has like a little bar or a pause button over the top of it. If you select this, down near the bottom, you see where it says show menu bar? Right there. Click show menu bar. Now you have a whole additional row of commands. Everybody see that? So now you have lines and curves. So there's multiple ways you can create lines and curves that surveyors would find useful. Okay. I'm going to create line. So the two that you're going to need to know are line by northern and eastern. So that's if you know the coordinates from the NGS station. And then line by angle. Could you also do line by azimuth? You could, if your azimuth is straight up the whole time. I find turn by angle is more useful. Okay. So let's get a line from the benchmark Centennial to the spire at Cole. Okay. I already wrote down the northerns and easterns from the NGS station. Everybody's okay to go and retrieve this on their own. Yeah. Cool. So line, create line by northern and eastern. Always be looking at the command line because it's going to guide you into the right direction. See where it says enter northern? Be careful. In CAD, when you tell it to draw a line, it's X comma Y. This is asking for northern, which is your Y coordinate first. Okay. So for Centennial, it's 507.214.45. Now it's asking for the easting, 2,673,119.33. Please check me and make sure when you do your own that I didn't transpose a number. Do I make mistakes? You are damn skippy, I do. Right? All right, so northern 507.194.31. So now I'm entering the coordinates of the spire at Colton Chapel. 2,672,995.5. Okay. I just drew a line. Who sees it?
Computer.
The computer sees it. If I do ID, whoops, ID, where am I? Nowhere near that line, right? So if I want to see where that line is, just type C for zoom, enter, and then E for extends. See how I have a little dot and a little dot? Okay, so another thing you need to do is type units. And your length is in decimals, but you also have decimals of a degree here. So you'll want to change that to degrees, minutes, and seconds also. And you'll want to change the precision of that also. Okay. And then hit OK. That's the geo marker. So in terms of what it is and what it does, it's not really important to what we're doing. Yay, I have a line. So if you go to your inquiry tool and you want to know, actually, let's use geodetic calculator. Go from endpoint. So you pick this for the point, and then endpoint. It's telling you. Interesting. Yeah, it's 7653. Something's not right. What was that?
The little red dot is the benchmark, then why?
Well, no, that's not the benchmark. That's something completely different. I will mess around with this a little bit more to figure this out, but it should be doing, for some reason, it's giving me different units than what I'm expecting. I will figure that out and give you the solution on why it's doing that. But for now, let's go over how to do turned angle. So let's assume that this is working. So that little red dot is the geo marker. So if you type geo marker visibility and type 0, I'm just going to turn that off because it's not really significant for what we're doing. Okay. So now, if you're going to do line by angle, okay, you may or may not have started looking at RD or pole. Okay. So for starters, we're just going to draw a line. So when you first draw a line, it asks you dot P dot M or dot G. Okay. That dot P is if there was a point on it. Okay. The dot N is if you knew a northing and easting. The dot G, I forget because I don't use it. But what I'm going to do is just select another point. So line, triangle, I'm going to grab a point. I'm going to turn ortho on, right? It doesn't really matter what this first line is. I'll explain why in a second. See how it's giving us angles 73, 30, 48. Your decimal point goes immediately after the even numbers of degree. And then it's minutes and seconds, but the minutes and seconds, you don't put another decimal. So if you had 30 degrees, 45 minutes, 15 seconds, that's how you would enter. There's 30.4515. It's not actually entering it as decimals of a degree because you've switched the unit base to read degrees, minutes, seconds. Okay. Notice how you can tell it angle left or angle right, depending upon if you went clockwise or counterclockwise. So I gave it an angle. Now I'm going to give it a distance. 500. Right? So that gave me the angle from where I was originally. So if you just draw a straight line, straight up the page, just as a starting point. Line, triangle. Now you're going to use snaps, starting from this end point. To that end point, 30, 45, 15, 500 feet. I wonder if it's because I had. I know what it was. So clockwise or counterclockwise. So if you want to do counterclockwise, you tell it here, C for counterclockwise. But it should be taking the angle, which it did. And it should be taking the distance. What's that? Right, but it didn't draw the line that I asked it to draw. I'm gonna have to,
You think like when you type that one, it just makes you slide with it, but it doesn't draw it. So you gotta like maybe bring that through again or something.
let's try that.
Try zooming in on it, like 500 is a really small one. Compared to everything else.
Good call. Yep, that's what it is. Thank you. That line was a really long line. Good call. So that got you your next location. So that, to your next point, then by turned angle. So now you select endpoint of that line. What was your reference? Your reference might have been back to this endpoint, right? So now you'll tell it either angle right or angle left. To get angle left, counterclockwise, so you hit C. Okay. So now I'm going to say that it was 60, 15, 35 for 1,000 feet. So if I go to inquiry, angle, this first angle, right, is 30 degrees, 45 minutes, 15 seconds. The second angle that I entered was 60 degrees, 15 minutes, 35 seconds. Yeah.
How do you reference the angle off of a certain point?
Okay, so when you first select, yep, good question. So when you first select the command, so you select line by angle, and it's asking you where you want to begin from.
Okay.
So now you're going to use your snaps because you have to pick the actual end point of this line. So you type the word end, and you see how it gives me that little greenish colored box? Now you're selecting the end of that line. Now the next thing it's asking you for is that reference.
Okay.
So now you're saying, okay, my backside is where? My backside is this last line. So if you just type end again, a second time, and select that, now you see how it's saying, okay, where's your angle? Now you tell it clockwise, counterclockwise, what the angle is. Again, if it was 135, 45, 15. The angle between here and here is 135, 45. I need to mess around with the units and the distances to figure out why that's not giving me the coordinates I was expecting. So we'll pick back up on this on Monday. Everybody follow kind of how to do, mess around with this on your own. The other thing that you can mess around with is you see this little Traverse editor. You can enter your angles and distances in this Traverse editor also. That's another option. I didn't go through this, but go ahead and play around with it, okay? Okay, that's it for today. I will see you all on Monday.
Thank you.